Now, if I'm graphing lines like this, then I need to know what the line is equal to first. So I'm going to ignore the absolute value to begin with. So y is greater than 2. I just want to draw y equals 2. So I need to know that y equals a horizontal lines going through 2 on the y-axis. Now, the same rule that we use when we graph these in standard form. If there's no equal sign here, then it means that this line needs to be a dotted line. So I'm going to go ahead and change that. And for greater than questions, as long as this is a positive y, which it is, we're going to shade above the line. So in other words, everything here. And if I pick a point up here, for example, this point here, 2, 4, then look at the y value, it's certainly greater than 2. Whereas if I pick a point down here, say 0, 0, here's the y value, this time 0, is that greater than 2? Well, no, and that's why that side of the line isn't shaded. So we can use that as an additional check too. X is less than -3, or equal to -3. So x's are vertical lines. So vertical line going through -3. Slightly off on that. Let me just move that across a little bit. There we go, it's better. It says equal to, so this is definitely a solid line. And for this one, I can't really use the above or below thing. But for vertical lines, just go the side the arrow points to. So this says less than, this points to the left. So we're just going to shade to the left of this line. If this had been a negative x, then I would divide both sides by a negative number, which would flip the inequality, and then I would go ahead and graph this. We'll leave that one for now. And we'll leave that one for now too. So these are really the ones I want to focus on, the ones that are in slope-intercept form. So we want to go back to how we did this before when this was just equal to. So any slopes that aren't fractions, we're going to make them into fractions. So just put them over 1, and that will make them into a fraction without changing the value at all, because 2 divided by 1 is 2. So what we do is we start off by looking at the end number, which is our y-intercept. And then we use the slope to find other points. So remember, this is the rise and this is the run. So I'm going to rise 2, run 1. Rise 2, run 1. And as far as I can, go in that direction. Now, once you've figured out a pattern, you can also do this backwards. So I can see from here, left 1, down 2, left 1, down 2, left 1, down 2. And I can get plenty of points on my graph. Once we have all those points plotted, go ahead and join them up. And notice for this one, it's not equal to. So actually for this graph here, I need to go ahead and make this a dotted line. Like that. It says greater than, and this is for a positive number of y's, so that means I'm going to shade it above the graph. So just go ahead and shade everything that is above that line. Now I can do this with fractions as well. So this one's actually probably easier because we already have this as a fraction. This is my rise, this is my run. So fractions are actually easier than doing integer values for once. So my starting number on the y-axis is 2, positive 2. And then the slope for this is 1 over 2. So I rise 1, run 2. Rise 1, run 2. Rise 1, run 2. And I can complete this pattern backwards as well. Enough points as you need such that you can draw a straight line through all of those. Now notice this time it does say equal to, so I'm going to leave this as a solid line. This is a positive y, it says greater than, which means I'm going to shade it above the line. So in other words, everything up here. Let's go to possibly the worst question, I guess. X minus 3. So for this one, I know my starting point, I can see that here. I'm going to start with -3 on the y-axis. But for my slope, I don't actually have a number at all. It just says x. So we have to remember that means 1x. And as we have to write it as a fraction, we're just going to put 1 over 1, which is just 1. So rise over run, I'm going to rise 1 square, run 1 square. And I'm going to do this as many times as I need so I can get to the whole graph completed. I can connect this up with a line. And for this one, no equal sign. So that tells me that I'm going to need to do a broken line for this one, or a dotted line. There we go. And it says greater than, and this is a positive number of y's, which once again means we're going to shade above the line. So we're looking at this part here. Actually, let's go back to this one, because this also has something slightly interesting in it as well. And this one actually has no starting number. So if there's no starting number, that means that it must just be 0. And we're never going to write down plus 0. So we're going to start from 0. I already got my fraction, so rise 2, run 3. Rise 2, run 3. Rise 2, run 3. And I think I got enough to draw. Oops. I think I got enough to draw my graph in here. Equal sign, so I'm going to leave this as a solid line. This one says less than. For a positive number y, it means I'm going to shade below the line. So in other words, this part all the way down here. And as you can see from those examples, once you've got the idea of drawing those graphs, it's actually a fairly quick process to go ahead and actually draw a graph that's in slope-intercept form. Very aware of those first few though, the x equals and the y equals. Those vertical and horizontal lines often catch people out.